Hello students, welcome you all. In pericyclic reaction, today I will discuss Nazarov reaction or Nazarov cyclization. So this reaction is an example of electrocyclic ring closure in which if we take 1,4-pentadiene 3-one and its derivative, then in presence of heat or light, it converts up into cyclopentenone or its derivative. So some of the main points for this reaction. So suppose here if we take 1,4-pentadiene 3-one and its derivative, then this converts it into cyclopentenone and its derivative and its derivatives. Okay, so this is an example of electrocyclic ring closure, and this is an example of 4n electron system. So it is an example of 4n electron system. So it follows the selection rule for 4n electron system. So what was the selection rule, electrocyclic selection rule? So suppose if we have 4n electron system, then under thermal condition the orbitals will undergo conrotatory motion, whereas under photochemical condition orbitals will undergo disrotatory motion. So this is for 4n electron system. So this Nazarov reaction is an example of 4n electron system. So otherwise we know that for 4n plus 2 electron system, this just reverse. So under thermal condition disrotation and under photochemical condition conrotation. So here we are concerned with this selection rule for 4n electron system. Under thermal condition conrotation of orbitals takes place. So it means that under thermal condition conrotation or electrocyclic ring closure will takes place with the conrotation of orbital. So under thermal condition here electrocyclic ring closure takes place with conrotation of orbital. Conrotation of molecular orbitals. And we know that when conrotation occurs, then stereochemistry of the substituent changes. So here when conrotation takes place, then in product stereochemistry of substituent changes. So here stereochemistry of substituent, not orbital, stereochemistry of a substituent changes in product. Okay, and under photochemical condition disrotation will take place. Under photochemical condition disrotation will take place and stereochemistry of substituent remains same. So under photochemical condition electrocyclic ring closure takes place with disrotation of orbital, and here the stereochemistry of substrate remains same in the product. So stereochemistry of substituent remained same in product. Okay. So these are the some points, and here the reaction starts in acidic medium. So reaction starts in acidic condition. In acidic condition, either for example, a reaction can take place in presence of sulfuric acid or phosphoric acid, or some Lewis acid, we may take Lewis acid. So here, but this acidic condition is not related to this ring closure reaction or electrocyclic ring closure reaction. So this electrocyclic ring closure, it doesn't it is not concerned with this acidic condition, because it only requires the either heat or light. Okay, so this is only for the start. So the reaction starts under the acidic condition as a catalyst, we can say. So for example, if we take 1,4-pentadiene 3-one derivative, suppose, and its derivative. So suppose I simply take 1,4-pentadiene 3-one. So this is 1, 2, 3, 4. 1,4-pentadiene 3-one. So this is third carbon. So this in presence of acid. This is just for the start. And finally, if we either heat it, either in presence of heat or light, either in presence of heat or light, what is formed as a product? Cyclopentanone is formed as a product. Now, so how the reaction will take place? So first of all, in acidic medium, the protonation of this starts. Protonation of this oxygen will take place, and what we will get? Positive charge will come over the oxygen. Now we may write the resonance stabilized structure for this. Now the positive charge will come over this carbon, and we have OH. Okay. Now under thermal condition, suppose under thermal condition, what? Under thermal condition, Cohn rotation will take place. Under thermal condition, ring closure with a Cohn rotation of orbital, and stereochemistry of substituent changes in product work. So here under thermal condition, this cyclic shift of electron will start. This positive charge will get neutralized. New positive charge will come at this carbon. So what we can write? We may write this will undergo ring closure. New sigma bond is formed over here, and one of the new pi bond is formed here. One of this positive charge and this. Okay. Now here if you see after this ring here, hydrogen is present. Okay, there hydrogens are present at this position. So here the hydrogens, suppose either both hydrogen same, if same substituent, then there is no question of this stereochemistry. So otherwise, suppose, so if this hydrogen is present, then one of the hydrogen we may write like this. This is one of the hydrogen, another hydrogen. Suppose stereochemistry changes. Suppose both are cis, then here one, it will be changing to cis trans. That will be changing to trans. So here Cohn rotation and stereochemistry changes. Okay. Now another, or what we may write, another product that we may write, this may be the another product. This may be the below the plane, this hydrogen it may be above the plane. And finally, what we can write, the positive charge that should be neutralized. So this positive charge will be neutralized after the removal of this H plus. After the removal of this H plus, this will get neutralized. So what? Here we will get Now, so this thing. Okay, so this should be the product. Now this can be written in a tautomeric form. And we get cyclopentanone. Here one of the hydrogen above the plane, another hydrogen is below the plane. Another hydrogen is below the plane. So this would be the product. This would be the product in this case. So this takes place under thermal condition. Suppose if we have a photochemical condition. Under photochemical condition, disrotation of orbitals will take place. So if disrotation of orbitals and then the substituent means this hydrogen, if they are present, the stereochemistry of hydrogen remains same. So if here they are cis, then in product also they will remain cis. So both either they will be above the plane or both hydrogen that would be below the plane, and finally the product form would be same. So what we may write either the either I may write both hydrogen above the plane or both hydrogen below the plane. Okay, so this may be written, and finally the positive charge will get neutralized, and after the removal of this positive charge, so this will get removed and we will get the same product here. Same product we get after the removal of this H plus. Okay, so this is when I have taken simply 1,4-pentadiene-3-one. Now suppose I take here H, suppose I change it, if it's I take the derivative of this and I put R over here, this one and this one. Then in product what you will get? In product you may get either you will get here this one as a product or another product. This will be the R is below the plane or above the plane. Okay, so like this. And otherwise, suppose here if these two are in different positions, so here both is going outside, both R is going outside. Suppose both one of the R is going outside and another R is going inside. Okay, then in that case what should be the product? So here under thermal condition, the stereochemistry will change and the product form that will be cis. And the photochemical condition here, because this is trans or this is trans, then under photochemical condition the product would be trans, and under thermal condition product would be cis. So what would be the product in this case? Suppose I write this one, and product form in this case will be, suppose I take a thermal condition. Then product would be okay. So this is trans. So under thermal condition, the trans that would be changed into cis. So this would be the product. Okay, and under photochemical condition, the product form that would be so both this alkyl group or this R, that should be either above the plane, it may be above the plane or it may be below the plane. So this would be one of the product, and another, the enantiomer that can be formed, another enantiomer which is possible here. This is the another enantiomer which is possible. In the same way, here also either both will be above or both will be below. And finally, we have to remove the H plus to neutralize this positive charge. So here the positive charge that would be neutralized from here, one of the H is present over here, H is present over here, and this positive charge would be neutralized. And product formed, this would be the product. This is one of the product, and this would be the another product. This would be another product. Okay, sorry. So here this would be the another product. Now for this, here also you will find the same product will be obtained after the removal of this H plus. We will get the same product. We will get same product after the removal of this H plus. Okay, so these are the product under thermal condition and the photochemical condition. Let us take one more example. Now suppose I take another derivative of 1,4-pentadiene-threone. Okay. Now suppose this is an example, then how we will proceed here? So in this case, again in presence of H plus, this oxygen will get protonated and we will have okay. Now in next we may write its resonance form, and we will have a positive charge over here. Okay. Now electrocyclic ring closure in thermal condition, electrocyclic ring closure will take place. Now question is that where the positive charge will come. So where the double bond should come. Either here double bond may come or the double bond may come at this position. Okay, so the double bond that will come at this position, and here if you will see, this is one of the possibility that double bond comes at this position, and another possibility that double bond may come here at this position. Okay, so means in this case what should be the product? The ring closure, electrocyclic ring closure, and you can see the double bond, the new double bond is formed over here. This is the new sigma bond which is formed, and the positive charge is coming over here. So if you will see, either the positive charge may come at this position, or in another case the positive charge may come at this position. So what is the correct one? So this is the correct one, because the positive charge that would be neutralized by the removal of this H plus H which is present over here. Now, if you see the position of hydrogen at this here, because here the Kohn rotation will take place. On Kohn rotation, the hydrogen which is present over here, that would be one of the hydrogen that would be above, another hydrogen that would be below. Now, so this positive charge, either it may be neutralized by this H, okay, either it may be neutralized by this H, or it may get neutralized by this removal of this H. So I should remove this hydrogen. So if I remove this hydrogen, and the product formed, that would be okay, this would be the product. Or otherwise, if I remove hydrogen, this hydrogen, then product formed would be, this would be the product when I remove another hydrogen. So this would be the next product. So but this is more, this is a major product, this is a more stable, because this double bond is in conjugation with this phenyl ring. So that's why this is correct and this is incorrect. And finally it may get tautomerized, and after tautomerization we may write this one. And the enantiomer of this may also be formed. So enantiomer of this, that is where the hydrogen, the stereochemistry of hydrogen may be like this. This will be the another product which is possible. This is another product. So these two products that would be formed in this case. Okay. Now this is under thermal condition. Under photochemical condition, if you will see under photochemical condition, disrotation of orbitals will take place, and after disrotation here, the stereochemistry of hydrogen, that will be same. That is, either both the hydrogen will be above the plane, or both the hydrogen that would be below the plane. So the product formed, that here in this case, the final product which is will be formed, that would be, this would be the final product. Both hydrogen below the plane and both hydrogen above the plane. Both hydrogens are above the plane. Okay, so this should be the product in this case. Now similarly, if I take next example, now okay. Now, here what should be the product? Now, in presence of H plus and under thermal condition, the one of the intermediate that would be formed. So here OH will come. In the same way, I may write the product in the same manner. So and here. So the positive charge, so if the positive charge I have placed the positive charge over here. Now here again the positive charge that should be here, not here. So in this case the product, which is I should write this would be the intermediate in this case. Okay, and another one, the position, this R, the stereochemistry of this R or enantiomer of that, this may be produced. And now the H plus that would be removed. So I should remove the H plus from here. Okay, and sorry, one of the like this. Okay, and here the product. This one and an enantiomer of this one, an enantiomer of this one that would be formed. In the same way we may write the reaction in presence of in photochemical condition, and in photochemical condition we will have the either both R that would be above and both R that would be below the plane. So this is about Nazarov reaction or Nazarov cyclation. Thank you.